Hello everyone, this is Husham Al-Naseri. I am research assistant and I am going to present this research evaluating the impact of selected design parameters on interactive daylighting analysis. Today's agenda will be going through introduction, background, methodology, results and discussions, and the end conclusion. Previous studies have emphasized the impact of daylighting in human health and well-being while addressing the perceptual aspects of daylighting in terms of occupants' point of view. So what is missing? Which is, although some buildings characteristics like location and orientation are decided very early in the design stages, other design preferences to impact daylighting are left to the final stages. So this study investigates how changes in interior, such as shading and furniture, and in exterior, such as vegetation and trees, would affect the amount of daylight observed by the building occupant in a campus building by using two software applications as Radiance from IES and Insight from Autodesk. The result of the study will be used to improve daylighting performance of sample building and show correlations among building design parameters. The vast majority of our time spent indoor, at least 40 hours a week spent in office and classrooms, in addition to the positive impact of the daylight on health and well-being of the occupant, daylighting can have a significant impact on energy use in the building. Considering the effectiveness and accessibility of energy modeling tools, this study utilizes Autodesk Revit to create the 3D model of the campus building and IES and Insight to perform daylight analysis on the building, interior and exterior. So in order to evaluate the impact of design parameter in this study, interior and exterior parameters are changed in the building design to impact daylighting performance. Furniture, orientation, interior, and vegetation, exterior will be used as the main two parameters to evaluate and improve daylighting. This study has followed a step-by-step approach. The first step includes the creation of a 3D model of the seed building in Thomas Jefferson University's East Fall campus located in Philadelphia, Pennsylvania with Autodesk Revit. Seed building is composed of a first floor and a mezzanine floor spread over 14,000 square feet. The building is used for faculty offices and the classrooms. Passive design features are extremely important in daylighting analysis. The building has aluminum window system and sunshade which are placed on all sides of the building. The west side has the entrance with double doors. The analysis was performed over the semi-open areas of the building. There are curtain walls all around the building. Since IES cannot directly get Revit models as an input for simulation, similar geometry of the building was created in IES based on the details of the BIM model. IES from Radiance is a powerful daylighting analysis tool which simulates daylighting conditions under different conditions to help improve the well-being and productivity of building occupants. For Insight, a detailed BIM model for the building has been used to perform daylighting simulation due to the software's ability to work with Revit files directly. Seed building's 3D model as well as passive design strategies were reflected in the model used in IES and Insight. In both software applications, daylighting analysis included setting up daylighting parameters and inputs. In order to compare apple-to-apple, parameters were set in the same range in both IES and Insight. Both software tools generate two metrics and graphical output based on the point-in-time dataset. Location was set as the address of seed building in Philadelphia. Weather conditions are defined based on the location data. CIE, standard sky conditions, were used in both tools. This physically accurate sky model is recognized as an industry standard and controlled by two illuminance values to be chosen as overcast or clear. This is defined to set the work plane of interest and to provide a base for accuracy of simulation. Selection of the analysis grid and specific nodes within the grid work plane allows hourly luminance values to be calculated over a year in case an annual daylighting simulation is performed. Specific node can work as a daylighting sensor, especially in Insight due to its link to the Revit file. It is possible to draw an analysis grid to perform daylighting analysis in a specific area, as it was done in this study. Trees and other biophilic element has defined as outside the building, which can be changed in the 3D model upon performing the daylighting analysis. Interior elements such as location of semi-permanent or movable objects like shelves, furniture, etc. For the study, 5 simulation scenarios were created in each software application. First is the 3D model without trees. Second is the 3D model with the trees outside the buildings. This image shows the location of trees in both softwares. Third is the 3D model with extra use of curtains on windows located on the south side. The fourth is the model with furniture. And lastly, model without furniture. So the fifth step is perform daylighting analysis. IES and Insight give similar metrics in a scenario without trees and vegetation around the building. While both programs use CIE standard sky conditions, each software interpreted trees and curtains differently. Transparency of trees and curtain are components in Revit determine the amount of light that pass through these objects. The value of transparency was set to 90% for both trees and curtain in Revit. A default 3D cherry tree has been used in both softwares. IES calculated the impact of trees using reflectance and roughness of the trees. Dimensions of the trees were selected to be the same in both softwares application. When trees are included, excessive shading and a considerable decrease in IES is observed in compared to Insight. While curtain was modeled using in-place mask tool, IES provided default curtain for windows. The impact of the curtain in IES was determined by a parameter called shading coefficient. Since white linen was assumed in both programs, the shading coefficient in IES was set to 0.54. It creates similar results in both software applications with a decrease in lux values. The study investigates how change in interior such as shading and furniture and in exterior such as vegetation and trees would affect the amount of daylight observed by the building occupants in campus building by using two software applications as IES from Radiance and Insight from Autodesk. With similar parameters set, they ended up validating one another's results, except the case of result with trees. Metric results showed a significant correlation between the lux values of IES and Insight. Daylight and Insight with the daylighting values. Both IES and Insight were found successful in daylighting analysis under changing design parameters. When the software tools were analyzed, with and without furniture, graphical and numeric representation resulted in similar metrics in terms of flux values. This suggested that the inclusion of additional furniture as interior element didn't considerably affect the daylighting values. On the other hand, when another interior object such as curtain was added to the model as a shading device, it created similar results in both software application with a decrease in lux values, even if regular windows were in place without shading. Findings indicated there is a considerable impact of changes of interior and exterior element on daylighting performance. As these elements are mainly created in Revit, the advancement and properties of the Revit model should be considered in daylighting analysis. Revit gives various options in the information as well as the appearance of certain elements like vegetation that can drastically impact the results of the daylighting analysis. As an example, Revit allows transparency to be changed in trees. Users need to decide how much transparency should be used for vegetation in the Revit model to mimic the actual case as much as possible and to produce reliable daylighting simulations. As-built daylighting analysis will only allow change minor features in a building that may not improve daylighting as needed. So for the future studies, daylighting parameter can be configured in Revit based on the details and properties known and required at different phases of a project, such as design development or construction documentation. This research was conducted with the support of Thomas Jefferson University with associated faculty research grant entitled Interactive Daylighting Analysis in Virtual Reality. Thank you for listening.